All right, we are going to do this review sheet together, and we're going to start with lesson 12-1 that goes over the coordinate grid. So when you have the coordinate grid, we know that we have 4 quadrants. We have an x-axis and a y-axis, and you have to watch out for your increments. In this case, each square is only worth half of a unit because it takes 2 squares to get up to 1. And then 2 more squares to get up to 2. So you have to pay attention to that stuff. We want to know what ordered pair represents the location of S. S is over here in quadrant 3. Okay, so first of all, we know that S is in quadrant 3. And we know that quadrant 3 is going to have a negative x value. Okay, it's going to have a negative x value. It's also going to have a negative y value. So that's a strategy to eliminate some answers here because we're looking for a coordinate that has a negative x and a negative y. Well, that eliminates this one, this one, this one, and you're left with D. Okay? You can also just find the coordinates by going on the x-axis. You're going over negative 1/2, and then you're going down on the y-axis, which was negative 1.5. So negative half for the x and negative 1.5 for the y. Either way that you choose, you're going to get answer D. For number 2, we want to place an x in the appropriate cell to identify the quadrant in which each point is located. Okay, again, I think it's very helpful to identify the signs for each quadrant. In our first quadrant, we have plus plus. We have a positive x and a positive y. In quadrant 2, we have a negative x, still a positive y. In quadrant 3, we have negative x and a negative y. Quadrant 4, we have a positive x, because we're going this direction on the x-axis, and a negative y, because we're going down on the y-axis. So, based off of that information, let's look at our first choice. It's negative, negative. So that's quadrant 3. Okay, I'm going to label these real quick. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Okay. This is positive, positive. That's quadrant 1. This is negative, positive. That's quadrant 2. This is positive, negative. That's quadrant 4. Okay? All right. Number 3. The table below shows the locations for several different points of interest in a museum. The grid shows a map of the museum, and each square represents 1/2 hallway. This is very important. They're telling you that each square represents 1/2 of a hallway, whatever that means. Okay, that means that if I'm moving a hallway, a full hallway, I would have to move 2 squares to move 1 full hallway. Rico goes to the artifact exhibit, which is 2 hallways south and 2 hallways west of the statues. Give the coordinates of the artifact exhibit. So we're looking for the artifact exhibit, but we're told that he starts at the statues and goes 2 hallways south and 2 hallways west. So let's find the statues first of all. We have a positive, positive coordinate. That means we're in quadrant 1. The only spot in quadrant 1 is here. So this must be the statues. Okay, and we can double check because we have 2, 1.5. We are over 2 and up 1.5. That's the statues. Now, we're moving 2 hallways south and 2 hallways west. Remember, each square represents only 1/2 of a hallway. So if I want to move 1 hallway, I need to move 2 squares. If I want to move 2 hallways, I need to move 4 squares. 2 hallways south. 1 full hallway. 2 full hallways. Then 2 hallways west. 1 full hallway. 2 full hallways. And I end right here. My x-coordinate for that on my x-axis is still 0. Okay, I never went to the right on the x, I never went to the left on the x, I am right at the origin. So my x-coordinate is 0. My y-coordinate, though, I went down 1 square, and that's half. So my y-coordinate is negative half. Those are my coordinates for the artifact exhibit. All right. Lesson 2 in this module was about reflections of points. And what you have to remember that with reflections is if you have a coordinate and you reflect it across the y-axis, that means that I fold my paper along the y-axis. So I reflect my point over here. If you reflect it across the y, then your y-coordinate is going to stay the same, but your x-coordinate is going to change signs, because notice that your x-coordinate goes from being negative side of the x-axis, to the positive side of the x-axis. So let's say that this was the coordinate -3, +4. If I reflect it over here, I'm still going to be at the same y-coordinate. I'm still going to be at +4. But now I'm going to be at a +3. Okay, so reflecting across the y-axis means that my y-axis stays the same. My y-coordinate stays the same, but my x-coordinate changes its sign. So let's take a look at this. Which ordered pair is a reflection of 10, -19 and 3/8 across the y-axis? Reflecting across the y means my y-coordinate will stay the same, and my x-coordinate will change its sign. So my y-coordinate needs to be the same. That's this one. And my x-coordinate changes its sign. Choice B. Number 5 says, write the ordered pair that is a reflection of -6.5, 4 across the x-axis. Well, if I'm reflecting across the x-axis, the x-coordinate has to stay the same. So I'm going to go ahead and put that down, -6.5. What's going to happen to the y-coordinate? It's going to change its sign. So it was positive, now it's negative. Lastly, question 6 says point B has coordinates of -3.75, -8.25. And it is reflected across an axis, it doesn't tell us which one, so that B prime, that's how we say this, B prime with a little apostrophe, this is a reflected point, has coordinates 3.75, -8.25. So we had originally -3.75, -8.25. Now we have +3.75, -8.25. Identify the axis which the point was reflected, across which the point was reflected. Well, which coordinate stayed the same? The y-coordinate stayed the same. So that is the axis of reflection. Now, lastly, we have to choose from all of these statements. Tell which one is true regarding the reflection of the point A, 3.5, -4. Select all that apply. Be very careful on these, okay? First one says, the reflection of A, 3.5, -4, across the x-axis can be represented by A prime, -3.5, -4. Well, if it's across the x-axis, the x has to stay the same. Did it? No, it did not. So that's false. Let's look at B. When this point is reflected across the y-axis, the x-coordinates are opposite, and the y-coordinate stays the same. Okay, y-axis reflection, y-coordinate stays the same. That makes sense. And the x-coordinates are opposites. That means that the sign's flipped. Yep, that works. C. When this point is reflected across the x-axis, the x-coordinate stays the same, and the y-coordinates are opposite. Okay, go back. X-axis, x-coordinate stays the same, y-coordinates flip. Yep, That's true. All right, let's look at D. The reflection of A, 3.5, comma, -4 across the x-axis can be represented by A prime, 3.5, comma, +4. X-axis, that means my x's better be the same. Yes, and my y's better change their sign. Also yes. That one is also true. E. When this point is reflected across the x-axis, the x-coordinate reverses its sign. No. X-axis means the x-coordinates have to stay the same, not reverse their sign, so we already know this is a no-go. Lastly, Farah sketched a map of the inside of the school building. She graphed the point P, 2.5, comma, -7 for the main office. The principal's office is located at P prime, a reflection of the point P across the x-axis. What's the ordered pair that represents the principal's office? Well, we had the point P, which was 2.5, comma, -7, and the principal's office is P prime, a reflection across the x-axis. So my x has got to be the same, 2.5, and my y has got to be the opposite sign. So that's a 7. All right, this is part 1 of the review sheet. I will post part 2 later.